Hi, hello everyone. I am Siddharth and today I am going to demonstrate the working model of real-time meeting room monitoring and reservation system. This automation system will help our company's employee to find a vacant meeting room easily. There are basically two units, two modules. What we see here is the transmitter module. Such module will be placed in each and every meeting rooms. And we have the other module, which is the receiver unit, which will be placed at every floor of the building, which will basically display which meeting rooms are reserved and which meeting rooms are vacant, and this can be easily monitored by our employees. Now coming back to the transmitter module, this is a portable device. As you can see, this can be easily carried and this is handheld. We have built this enclosure using plastic covers, and the entire enclosure is reusable and rescalable, and we can attach additional components to the enclosure if the circuit grows bigger. It's quite apparent that in the subsequent versions the circuit will become much complex, as we have planned to make the system entirely automated. We have kept the design as simple as possible. At the same time, we have kept the system very easy to operate. Now let's see what all components are used inside the transmission unit. This is a push button which the user has to press it in order to occupy a meeting room. Besides that, there is a battery unit which can continuously supply voltage for nearly a week, and we have the whole circuit placed here. Now let me just briefly go over the entire circuit, and this entire circuit governs the working of the entire transmitter module. The big chip that you can see here is a 40-pin chip, which is actually the microcontroller which we are using is Atmega 16 series microcontroller, which is basically the brain of the entire system. This actually commands and controls all other peripheral units that are attached to this chip. We have written all the code, all this code, we have just burnt all this code in this microcontroller, and all this code goes into the microcontroller in the hex format. And besides that, there is a power distribution board which supplies continuous voltage to all other chips that are attached to it. And finally, we have the RF transmitter circuit, which is operating at a radio frequency of 334 MHz. Since all the transmitter module will be operating at the same frequency, there is an encoder chip which helps us in sending different data bits in the same frequency channel. The encoder that we are using is HT12E, which consists of 8-bit address lines through which we can set or configure 2 to the power 8, that is 256 combinations of addresses. By using this, we can differentiate between different transmitter modules placed in the same floor. By the combination, I mean is we can place that many types of transmitter modules without any interference. In order to synchronize with the receiver module, we are keeping the address line similar to that of receiver module also. This will avoid interference issue up to a maximum extent. The encoder and the decoder are working at 433 kHz by configuring the registers by the microcontroller. All these are synchronized with the microcontroller and works as per the command that is sent by the microcontroller. Now, finally we have as you can see here, the pink switch helps us in setting the address bit lines. The transmitter and the receiver modules must have the same address line set in order to communicate, or else they cannot communicate if there is a mismatch. In other words, the receiver won't accept the signal that is transmitted by the transmitter module. In this way, we can avoid interfloor transmission interferences. Address line will be the same in all TXRS system in a floor, but the data bits will be different so that we can know from which meeting room the switch has been pressed. To avoid interference between one floor and the other floor, we have set different address lines. Finally, we have here the adjustable antenna, and we can vary its length to increase or decrease the transmission range. Now let's see what all components are used in the receiver module. Right now it's just a prototype and we haven't built its enclosure yet. The receiver module will be a central display unit which would gather all information from the transmitter modules and will show our employees which meeting room is vacant and which meeting room has been occupied. This will be placed at every floor and it has similar battery unit, a RF receiver, a decoder unit which will basically decode the data bit signals that are sent by the transmitter which are in the encoded format. It has an antenna attached to it and the address bit address bit setup switch. Now let me show you how both units work. Supposing this module, the transmitter module, is placed in a meeting room. The user has to press the red button to indicate that the meeting room has been occupied by him and it is reserved. Immediately it will show you the LED turning from green to red to indicate the meeting room has been reserved. Now what you see here, the LED here, it is showing as green. That means that this room is vacant. But as soon as I press this button, the status will change to red and the receiver unit shows that that particular transmitter module is now been used by the particular meeting room, actually is used by somebody else. Now what actually happens behind the scene is when you press the switch, it actually triggers the external interrupt which will override the normal functioning of the program, and the ISR, that is the interrupt service routine, will be called and it will execute all operations such as alerting the user, switching the transmitter module and the data transmission. This will in turn help us in lower power consumption, as we have implemented listen and slip concept to prevent idle listening which consumes more power. The microcontroller cuts off the power given to the transmitter module while idle. So we can ensure that this unit will be easy to maintain, as we don't need to charge the battery every day. The system will run for a long time if it gets completely charged. We have now we can see the alert LEDs blinking. This alert LED is blinking just to tell the user to press the button again if he wants to reserve the meeting room for a longer period of time, if he has more work. Now if I don't press the switch, that means that I have left the room and there is nobody else in the meeting room to press the switch again. Now we can see the status is green. Now let me show you the operation once again. The status turning into red. This shows that I am present in the meeting room, and we're just waiting for the alert LEDs to glow again so that I can show you how the alert LEDs alert the user and how the status will change from red to green if I don't press the press button. Now I was talking about the real-time clock. We have avoided to use the real-time clock to be more accurate. In other words, the real-time clock induces some time lag into the system. To reduce error in the system, we have used a counter in the Atmega 16 microcontroller which acts like a timer clock. We have devised this system in such a way to prevent interference if two transmitter modules transmit at the same time. There is very possibility that the two transmitter might transmit at the same time. That's the reason why we have implemented time per division multiple access algorithm in our code, which uses the system clock. Now we can see here the LEDs have started blinking, the alert LEDs. Now if I don't do any activity, the status is still red. This shows the meeting room is still occupied. This program written in the code that for the time being it alerts for a minute. Now we can see here the status changing from red to green as I didn't do any activity, as I didn't press the switch. Now what is happening here is, what I'm trying to say here is, we can customize as per our need, as this is written in the program. For now it is after 1 minute it is alerting the user, so we can code in such a way so that it can alert in 10 minutes, it can alert in 20 minutes, that the code can take care of. I was in middle of the system clock cycles, and I was talking about the TDMA, time per division multiple access. Now we're just making sure that no two transmitter module transmit at the same time to prevent interference. That can be handled by using TDMA. We have written code that will actually generate a random number, and it will create a microsecond time difference between the two transmission of two different modules, to make sure that no two transmitter transmit at the same time, and it will never overlap. The code has been written to ensure maximum efficiency and stability for the entire system. We have also implemented signal acknowledgement and other concepts. If there is any transmission loss, the system will be sending after a certain period of time, and we do acknowledge the signal that has been transmitted over the wireless medium. That is, the transmitter and the receiver acknowledge the data bit signal, and there is more data bits added to that data bit, so that it gets the so that it makes sure that it gets the entire chunk of data. So just going over the program, we have set the register configuration for the timer registers, global interrupt, and enable registers to count the overflow rate. The code has been neatly structured and well commented, as you can see here. So that's the basic way how the application works, and thanks for watching. Thanks for watching this video, and thanks for your time. Do send me your feedback and your suggestions. Thanks.